Hi, so this is Professor Daniela Bortoletto, the head of particle physics. So Daniela, what was your motivation to have a career in particle physics?
Well, let me first tell you that I started to get passionate about particle physics when I was actually very young. I was about 12, and I read a book about the revolutions in particle physics, brought in by quantum mechanics and relativity. I decided, though, to become a particle physicist after I was selected to be a summer student at CERN when I was in my third year of university. It was truly a life-changing experience. Not only I learned a lot of particle physics and physics in general when I was at CERN, but I was also amazed to see scientists from all over the world working together so well. And that really made it for me.
That's great. All right. And what fascinates you most about particle physics?
Well, we go back to the revolution of quantum mechanics and relativity. Particle physics is built on these two subjects. And by investigating the smallest particles, particle physics holds a lot of the answers about the birth and evolution of our universe, which I find truly fascinating. In fact, the Higgs boson itself, the particle that completes the standard model of particle physics, might be the key to answering many of these questions, which really makes the precision study of this particle extremely important. So I think that it's the truly fascinating aspect for me in particle physics, the connection between the small and the big.
That's indeed very fascinating. And what makes Oxford a special place for you?
Oxford is a large particle physics group. It's perhaps one of the largest in the world in a university setting. And this gives us the opportunity to look at the questions in particle physics through many different experiments. For example, we can search for dark matter in direct detection experiment. This experiment look at the signal of a dark matter particle that is going through an experiment often located underground, and it shakes the atom of the material in this experiment and could produce a signal. But we also can look for dark matter at the Large Hadron Collider, where we might produce dark matter. We also study neutrinos in experiment located in Japan, in the US, in Canada. And what makes it also very unique is that we have an extremely strong support group of engineers and technicians. And this allows us to make major contributions to the construction of experiment. So all of this capability together makes really our group extremely strong, and I would say extremely unique.
All right. Thank you very much.